Okay, you can start.
Okay, hi everyone. Thank you so much for joining us, and we're so honored to be able to invite Adam to join us for a little conversation about his math journey through Basis Independent. So hi everyone, my name is Irene Wang. I'm the current Vice President of the Math Circle, and also with us is Derrick Liu. He's also our Vice President. So in case you don't know, Adam is one of the founding members of the Basis Independent Math Circle. He is our current president, and he is a senior, and he will be leaving us next year. We'll all miss you, Adam. So he has led the Basis team to win many amazing awards. He qualified for AMO twice, including winning silver this year. And he also won a Stanford Math Tournament algebra round individual first place and led the Basis team to win 9th place for the team round. So Adam, I would like to start the conversation off by asking you, besides what most of us know, the AMC and the AMY competition, what other competitions or tournament did you participate in, and what did you like about them?
Sure. I mean, a lot of competitions I did were college-based, so they were mostly written. They were mostly they're mostly written by college students, undergrads. Tournaments like SMT Stanford, Berkeley, Harvard, MIT. There are a lot of like double college where like two colleges like come together to make a committee and write and make these competitions. What I really like about these is you can tell they're written by people who are very experienced with the competition math, environment, because these are the people who, did these competitions in high school. So it kind of feeds into itself. The people who write competitions probably did the same competition just in a previous year. So they definitely know a lot about it, and the committees just keep getting better as a result. And I mean, I guess I would say the competition format just doesn't really get old. I mean, I've been doing these for what, 8 years now, and they feel nice and new every time. There's always something fun or an especially nice problem to entertain. And, um, it takes a lot of work still though. Like it's always new.
Bust this man's bunkers.
So pretty much you don't like learn a few tricks and then be able to do well every time, right? It's always there's always something new. You're going to get under pressure, and you got to do the best you can. So getting top places is not you can't guarantee that. You're against a bunch of good, like probably equally good people. I mean, it's gonna take a lot to do well on these, and it's always a nice trip to do these. Yeah.
Thank you so much. So what tactics or methods did you find the most effective when you were studying for these competitions? And specifically, one of our students asked, how did you get ready for the AMY and USAGMO competition?
Okay, you probably know about this, but there is a website called Art of Problem Solving, AOPS. I can link it. But it has like all the previous years competitions. So for AMY and USAMO, it has all the problems. You can do these practice tests. I would suggest that okay, there are two ways to go about doing this. One way would be to do these tests year by year, but you need to make sure that you give yourself the proper time limit, and do it as if it was the real contest. Keep in mind that these problems are usually a bit easier than current years because the problems get harder every year. It kind of has to, because people start learning.
Angel，他们是不是在学校里啊？这个房子是不是学校？
And this is the way I used to do it, you just do the 3-hour time limit, go through the problems. Of course, it is sometimes the case that you're unable to do many of the problems in these contests. I think you should spend some time working through them instead of just instantly looking at the solution. So, I mean, a lot of these problems look challenging, but they can just be maybe like they're intimidating, but they're not too difficult. Like they're approachable if you put the time into it. So you definitely want to get yourself into that mindset of, trying a problem before giving up on it. And then of course, if you don't know how to do it, try to look at the solution. A good place to be is being able to understand the solution, but not knowing how to get to that solution yourself. Because at least you're learning something from this question and you know how to do similar questions in the future. That's like a really good spot to be learning. I think that's how you grow the fastest. And if you're stuck on like a specific type of problem, I think number theory was that subject for me. I was never really too good at those. And I'm still not the best at it. And I mean, there are some resources online that let you filter like past Amy Usajima questions based on subject, difficulty, and there are all sorts of filters. So if you want a very specific type of question, you can probably find it. I can also link to that in a bit. So the second way would be to focus on certain types of questions, and trying to master those, and getting yourself consistent with that type, getting yourself comfortable. But of course, that's only if you want to do self-study. And I'm very aware that self-study is not for everyone. So there are a lot of, summer camps or classes that can definitely help you. Be careful because, I mean, not all these classes are built for you specifically. So you should try and find an instructor who's willing to give their time to teach specifically to you rather than to a broader audience. So you'll find that usually with smaller classes. And give a couple examples. So if you're at the qualifying for Amy level, there are a lot of classes that kind of give you general knowledge. I can answer this later actually. If you want to continue.
Yeah, sure. Maybe you could talk about that, but do you have any specific suggestion about advanced geometry and combinatorics? One of our club members had wanted to ask about that.
Oh, absolutely. For geometry, it's very important that you draw to scale big diagrams. So definitely invest in some big paper and have like a compass and ruler, and always try to make your diagram as accurate as possible. And this seems like a small thing, but it's sometimes the case where if you don't draw an in-scale diagram, you might not be able to see a key observation that will help you solve a question. So definitely spend some time making at least one diagram. I think you should make multiple, and if there are like different configurations, it might be easier to see and confirm certain observations about the diagram. There are a couple, I mean, it's also very important to know common configurations, like angle bisector theorem, like at the Amy level. For more advanced questions, you might be looking at cyclic quadrilaterals, radical axes, things like that. For the USMO level, I would suggest reading Evan Chen's EGMO, which is, let me just, elementary Euclidean geometry for mathematical Olympiads. If you just search this up, you can probably find it. It's about like, I think $15. I don't really remember, but if you get it, definitely read through it. It's really good. for that level. But for the, the Amy level, I think the AOPS website was good enough for me. I could just find any geometry problem. Their books also, AOPS sells books. Those books are very good at getting used to common configurations in geometry. For combinatorics, that is a bit trickier. So usually these questions involve, big numbers, and like sort of maybe sometimes a little complex situations. So it's often the case that you can break combinatorics questions down. A lot of the common methods people use in combinatorics questions, like principle of inclusion, exclusion, pi, constructive counting, casework, all of these things involve breaking a problem down into smaller components and getting those components, those little pieces are probably much easier to solve than the big question. At the Amy level of combinatorics, not all these problems can be nice. In fact, the Amy is very infamous for having bashy and like kind of just bad combinatorics questions. And I would definitely suggest for those questions, I just suggest going through all the, if you know that this is going to be a bash problem, you should just go for it. Go get into, the details. A lot of times I see a problem and I'm trying to find this nice, clever solution, and I end up spending way more time, like a whole hour sometimes, just trying to get that nice solution. When in reality, there's no solution that's that nice, or there's no, like, that nice solution is super hard to see. So it might just be worth to go through that question a more conventional way, using casework or like a big pi bash or whatever, whatever works. But if you have a solution that is 100% going to work, that is often better than trying to find a nicer solution that'll save you maybe a couple minutes of time max. Yeah, so combinatorics is always about, or a lot of the times it's about breaking a problem into smaller components and then trying to work it through that way.
All right, thank you, Adam. So next, when you were studying for math competitions, did you ever feel like, you hit kind of a wall in your studying? Like, for example, you mentioned number theory earlier, and when you were kind of stuck in your studying, like how did you push past that barrier and how did you motivate yourself to keep on studying?
Yeah, I experienced a lot of slowness, toward the end of my middle school, start of my high school career in math competitions. It was like I was at the Amy level. I could consistently qualify, or 7th grade was my first qualifying year. And I think I was solid enough at that point. I was scoring consistent like 7s on past, practice competitions. But, I could never solve, any of the last half of the questions. And it was like that for a long time. And, even though I tried, doing more and more competitions, I found myself not being able to solve those questions even after the time limit expired. And, sometimes I can solve the first few and then get completely stuck and not do anything for the next maybe 2 hours. And that is a horrible feeling, and it really demotivated me and almost got me, to quit contest math, because I mean, it felt like I could never get to the level where I could do more than like 10 questions on the Amy. That was a high goal for me. So sometimes it's worth to just not feel that way. Set lower standards for yourself, and whatever's reasonable for you, try to go for that. And then another issue that I didn't realize at the time was that I just didn't know a lot of the facts that were being used in those later questions. Things like lifting the exponent, or just some advanced concepts that I hadn't learned. So having that, like lacking that information was definitely a part of not being able to solve those later questions. And I just figured I would read the solutions, uh, just Google some of the things that they were using and try to figure out for myself. But there are a lot of classes that are oriented towards like common things that are used at the Amy level or USUMO level or wherever you are. So those are definitely, breaking past the bottleneck does involve a lot of work, including, learning new facts, different applications of things you already know, and just not being so hard on yourself. Like the attitude is very important. And you'll often find that when you break past the bottleneck, you start going really fast again. And in fact, like once you get it, you get past it the first time, you can almost always like consistently get past it. Like it's a really funny phenomenon where like once you get past it, you can go way over. It kind of overcompensates. Um, and it's as if you never went through that bottleneck in the first place. So just don't like it, know that it's normal to be in that position, and use what I said to try and break past it. Yeah.
Yeah, it's definitely a common feeling. So like just as you said, if you were studying, how often would you study, like perhaps during the school, during the weekends, and even during like summer break or winter break? And when you were studying, like how long would you go without stopping? Like how long were your sessions and so on?
I cannot speak for everyone who is like in math competitions. I know a lot of peers who spend like 4 hours a day just going through USUMO problems and uh um putting all their effort into that. Um I think I was more of a self-study person, and I kind of just did math when I felt like it. It was a very casual thing for me. I did go into some more rigorous training like before the contest seasons. But mostly, whenever I'm bored in class or or have nothing to do, sometimes I just start doing questions. And like these questions can be official competition questions. I often just pull up an old contest and work through the questions. It's really fun to do these with friends, other people who are willing to spend some time doing questions with you. Um, I really appreciate the contest like preparation, maybe in like 8th, 9th grade for some of the college competitions. We would just meet up at a bakery or wherever, like a library, and just work through the questions, enjoy ourselves, maybe have some food. But it really helped build a connection there. So definitely try to find people who are like you, work through problems with them. Like it's always good to have a peer who's willing to maybe go over your proofs or bounce ideas. That's always a good resource. Um, and then by yourself, again, work through those problems. Just find any problems that you think might be fun for you. Not necessarily, I mean, yes, useful, but I like to prioritize like fun, interesting problems because it helps, you know, it stimulates the brain and it's a lot more enjoyable that way. Um, and then for time, I just like sometimes I do it for the whole day, and sometimes maybe just 20 minutes. It really depends on the situation, how willing I'm able to do it. But I never push myself when it comes to that. Yeah, I just sometimes during like homeroom period, or if there's any time between, my regular activities, I just go get out some paper and work through a question that's been on my mind. And sometimes I come up with my own questions, things that, seem doable, but I don't immediately know the answer to. Some of these little curiosities led me to some really nice results. Last summer, I was thinking about the question, and I made a talk on this like a couple weeks ago, uh, about like whether you can cut up a circular piece of paper and then rearrange it into a square. It wasn't too obvious for me, how one might do that, or if it's impossible. And it just got me to think about it. And after some research, it turned into a nice video and later a talk. So those are, I think, having the mind, of the problem creator is also very important, in getting better. So I did that a lot also so not necessarily studying, but thinking about um, contest math topics in it, sometimes coming up with your own, whatever works, pretty much. Yeah.
Okay, and then before we move on to talking about Math Circle, we like to conclude by asking, do you have any like general tips or just useful resources such as like books or camps or just opportunities in general for people who are trying to like maybe get into competition math or like competition research or math research, or like who want to go one step further into competition math?
Yeah, of course. For useful resources, there are a ton of free resources online. AOPS. There's also one of my friends built a website. One sec. Let me get it. Yeah, so there's like a AOPS reader. It's called Trivial. And it lets you pick, generate your own problem sets or like practice questions. It's all taken from the AOPS wiki, which is huge. It has like all the previous math contest questions. So you can just like, go onto this website, click on problem sets, choose whatever customization you want, and get the problems you like, however many questions you want, from, however recent or however old you want, at whatever difficulty you please. So, like, this is a pretty nice website to use if you're looking for those specific questions to improve on those more difficult questions for you. Uh, and there are also a lot of classes and camps you can do. So this summer I'm teaching at Alpha Star Academy. You've probably heard of it. But one really nice thing is they have instructors for each like specific level. So they divide it into all sorts of levels. Like it goes all the way down to pre-math counts up to math counts level AMC8, then 10, 12, and then Amy Usamo. And the really good thing that I'm really, this is why I like Alpha Stars, that they do things specifically for math competitions. They have their own team. I mean, they're a powerhouse. You often see them at the top of their leaderboards at any competition. And you can tell they're really good at preparing people specifically for those competitions. So Alpha Star, you can probably find classes for any level. The camps are going to be like 3 weeks each. It goes all through summer, and I mean you can pick any of them, any level. And in fact, there are, so for all the camps, you also have the levels and the subjects. So you can pick, you know, AME level geometry, that would be 40G. That would just give you a course in that specific subject, geometry. And it goes through 3 weeks. It's like 1.5 hours a day. So it's not a lot, but it's definitely rewarding if you put yourself into that. Other camps, if you're looking into more rigorous college level math, I did, so 2 years ago, I think I did Ross number theory camp. That was something that it was like more advanced, but also more classic rigorous number theory. So they really went down to the very fundamentals of, what is an integer, how you deal with numbers, formulations of numbers, rings, groups, fields, all that. It's really enticing stuff. So if you want to go into that, that's good for that. But of course, there are also some less selective programs. You can probably ask some of the other officials in the club for those resources, because I'm not too familiar with maybe some of the more common camps that you might go into, but I heard they're really good in terms of preparation.
Thank you so much. So, Adam, you're one of the best achieving mathematicians in the club and also as our president. How do you think you maximized your experience and participation with the math circle? Because I know that you helped us host the events like Math Talks, right? Is there anything else that you want to share about what you did with Math Circle?
Yeah, for members of the club, if you're still doing Math Circle next year, which I highly recommend, you should, so we currently have an official instructor for our class, Dr. Sega, and he has these handouts that he sends out like before the class. So instead of maybe just joining the class and listening along, that's great. But I think one good thing that you should start getting used to is downloading, printing the problem sets beforehand and trying those questions yourself, seeing how many you can do. It's really nice to do that, because often that is how you get the most value out of the questions on the problem sets. Because I mean, Dr. Sega's methods, so he usually works through the problems himself and selects them, so hand picks them for his handouts. So you often hear him saying stuff like, the method I used was not the same as the official solution. And I think that can apply for people working through these problems, like anyone working through these questions, just like working around the question, trying to get into it, and just seeing what you can do with them, because you might find a method that no one else has found before. It could happen. And it just gives you a nice bird's eye view of the question. After you tried a lot of things, maybe struggled with the questions, and when Dr. Sega explains his solution, you can kind of see a lot of the insights that go into that question. So the more time you spend with those questions, the better. And for other programs that BIMC offers, so stuff outside regular club hours, we host a lot of like competitions on site. Like this year it was BAMO. I think there might have been a couple more, but you should try and opt in for those. Even if you're not familiar at all with these competitions, it's always good to start early and who knows, you might do well. And it's just really good to have experience, accessible experience for those competitions. And I know, like, if you start early, you'll get better consistently. So just try and, if you find yourself not committing as much to maybe studying, you should try and look for those opportunities that give you that time to look through, try and solve these questions. And then also for the teaching events that, me and my great officials do, we do a lot of work behind the scenes. We've been trying to plan like a school competition. I don't know if it's gonna still be school-based, but this competition is looking very promising. It's still in development, but you might see that in the future. Basically, our goal is to make problems that they're problems that sort of mimic what other college competitions do, but like they try to maximize the thinking part of that. So not all the common tropes you might see in a regular competition. So, I put some work into that, and I think it's gonna turn out great, because we have so many like people with nice intuition and writing skills. That doesn't come out of nowhere. You need to have a lot of experience with math competitions to be there. So those are just some examples of things I, maximized from the math circle experience. Being able to work with these people and getting, some concrete stuff done.
Thank you so much, and thank you, Adam, for kind of advertising for us. So we are, we do plan to host a basis independent math tournament sometimes next year, and I know we have sent out some information about it previously in our basis parent Google Mail group. So if you're interested, please feel free to sign up. We did include some information in a sign-up sheet there. Okay, so thank you, Adam, about that. And then, so to continue to our next question, I know one thing that's on a lot of our older students' mind, especially for me and Derrick as we're juniors, right, is the college application that is sometime in the future and always coming near. So I know, Adam, you just, as a senior, you just finished your college application. Could you talk a little bit about how your experience with the Math Circle benefited you in your college application progress? How did you write about your club involvement in your application? And just any general tip you have for our student as we look toward this kind of scary thing coming up.
Yeah. First thing I would say is definitely write about it. I think it's definitely it's worth to write about your experience as a club member or anything beyond. Tell the committee what you got out of it and what you put in, because saying that you were a part of Math Circle, that's great. I think that's a good starter, but they need to see what is going on behind the scenes, because they are probably going to see thousands of Math Circle members from all across the country and beyond. So just having that is not enough. What really, so you want to put that in your activities list. A lot of colleges do ask for, your activities for your high school years. So for example, like the common application has about 15 slots where you can just put whatever activities you want. I'd like to see you guys put Math Circle on that, because right? But when it comes to writing about your experience, it's different for everyone. Try to be honest about your experience. So in future years, if you haven't done yet, try to first of all, work towards your goals, not other people's goals. It's good to define those goals yourself, and work hard for them. Maybe the goals don't need to be very high, but the story, what got you there, can be very convincing for college like admissions officers. So there's no need to inflate your experiences, but what you get out is what you put in, right? You need to have a very you need to be dedicated to this. It's not just like being able to work, look at, at whatever, attend the class. You need to, I'd say, be an active listener. Try to see what you can learn from each question. And yeah, those are some things that you should be aware of in following years. And of course, apply those to things beyond the math circle. Admissions officers want to see your impact, as well as the club's impact on you, as a result of attending this math circle. Because I mean, like, they want to see value come out of that class. So maybe you could use your skills as a mathematician, um, you know, maybe combine with that with your programming experience and make a predictive AI for whatever is coming up next. Just like having the mind of someone from Math Circle is very important. Like having math skills, being able to do math is good. Being able to apply math is good. Being able to think mathematically is the pinnacle of like mathematics. Like if you can do that, then there's gonna be like seeing things is going to be a lot easier for you. So for the application process, try to expand your horizons. Try to apply what you've done in Math Circle to some, maybe start your own like competition like we are, or join an organization and try to, offer them mathematical advice. Just, use your skills in whatever you're passionate about. It doesn't have to be math, but just make sure you're doing what you care about, because that's going to result in much better writing. So yeah, if you're dedicated to Math Circle, you should put in a lot because you're going to get a lot back. Even like getting awards at math competitions. If that's your goal, then go for it. Study hard, pay attention in class, and get that done. And you can write about that. Just it's about the journey, right? You can put all your achievements, those are just the destinations, but what you want to show them is that you can put in the work and get what you want, because that's the college students that they want, right? So yeah, put in as much as you want, but you should put in like more work into things that you care about. This applies for anything actually, not just Math Circle, right? Yeah.
Yeah, thank you for that. I'm sure many of us appreciate your college advice. So tying back to a previous question where you mentioned how you like connected with Math Circle, I know you are graduating soon and like you're leaving us, but was there anything that you kind of like envisioned for yourself after like this experience for yourself or just for Math Circle in general? Or was there like anything that you like hoped you could have achieved there during your Math Circle time, or you want like Math Circle to grow, etc.?
So I guess I just start with saying that there's not really a lot of things that I would change about my journey as a club member in this club. I think what we did as a club and as a team, it's really impressive already. I'm not, I don't really have many regrets. Um, a so in the future, of course, I'm considering giving back a lot to the math oriented community. That might be in the form of writing for my college's test, whatever competitions they offer. It might be interning at one of my at Math League. Math League has like these middle, elementary, high school competition championships. They were really exciting for me. Those are like the first ones that I did. So being able to loop back and intern for that over the summer, maybe next few summers, that might be worth it. But I also acknowledge that my time as a high school student is ending, so I won't be able to participate in a lot of the competitions that I enjoyed in high school and before that. It was kind of sad for me. But then I have to move on from it. There are a couple things past high school, college, collegiate competitions like Putnam. Those are always available, but I think what I achieved as a competition student, um, I mean, it kind of it can kind of end here. Um, I feel like what I got out of the competition experience will help me forever. But I think as far as the competition community goes, I might be done. That might change in the future because there's still a lot of opportunities for me. But I'm not going to be on the participating side a lot. But I do want to see, some of the rising, um, like future generations to be enjoying the same questions that I liked. I don't want to see this community die, and I know it won't, because there will always be smart people, people who are good at, math and thinking about math and always enthusiastic about it. So I do not see this anything about the competition community deteriorating in any way. I don't think about it like that. But yeah, in the future, I think the club, it might stay the same, and that's okay. But like I don't see it getting any worse after I leave. I think I was a I was a fine addition to the community, but I mean there are plenty of others who are just as good as me. I would say that can totally keep carrying the torch of BIMC. Some things in the future that I want to see. Let me think about that. Just like being able to, first of all, expanding the group. I know that like not everyone is willing to do this, and that's fine. But maybe expanding to, right, expanding past just basis. Like maybe you can find some schools in the neighborhood that are, willing to collaborate on all sorts of things, like other clubs do that. Other clubs do, you know, um, uh, do like these like multi-school like collaborations. So I think that could very well apply to Math Circle as well. There are a lot of other Math Circles also nearby. I used to go to San Jose Math Circle also. I think, reaching out to them and trying to get something cool with that community is great. It's just making more connections and seeing what you can do with that, because I mean everyone has their own ideas. Maybe if you pull together, those ideas might turn into great ones. So for and for I mean currently BIMC, right? It's gone a really far way since it started. I think this is very much on the like ever since we got Dr. Sega, our instructor, it's been different. Not necessarily for the worse. Like we used to have maybe like weekly discussions about math. That was more of the math circle that I envisioned, but I think having an instructor wasn't necessarily a bad idea either, because having that was a way to get our you know we could see farther than we did before, because now not only can we watch our actual classes grow, but we can see everything outside it grow as well. So having competitions that maybe we might not have been able to do before, now we can like travel for those, and like we can expand way past what we could do before. So like I especially thank Mr. Das for being there to get us to that point, being able to like put in so much of his time just to expand Math Circle beyond the the classroom, uh, you know um, just working out all the logistics and making things happen, right? I'm really grateful for him and his involvement with Math Circle as well, because we would not be here if not for his work. So thank you so much, Mr. Das.
Yes, thank you to Mr. Das. He has been like really instrumental for this whole math circle process, and he is also the one who helps like tremendously in hosting this interview and a bunch of our other math talks that hopefully we will keep on hosting next year. So maybe like a few final questions. So at Basis, we like outside of competition math or like Math Circle, there are like advanced courses. So there's like DiffEq, differential equations, linear algebra, and so on. So how did you like kind of connect your competition math with these advanced topics? And kind of sort of like that, did you apply mathematics to like other fields, and like how did you do that?
Yeah, I would say, of course, both of them are math, so there is some inherent amount of learning how things work. And one great thing in common with these advanced math courses and competition math is that you will see problems that you've never seen before in your life. Like maybe, and I think Basis does a good job in teaching these, where you just have these questions that seem unrelated, but are connected, to the course. Like you're saying differential equations. Yeah, you could talk about, the normal, whatever general equations you have. But I mean, there are a lot of applications outside that might surprise you. I mean, of course, there's some in physics. There are some differential equations. I mean, they appear everywhere pretty much. And they will always surprise you. And of course, competition math is also filled with surprises, right? So you're not going to be like advanced math courses aren't quite like the courses that, but pretty much everything calculus and before. It's different. So advanced math courses offer that, college level insight into how math plays into the real world, and maybe like if you're looking at pure math, how you can slowly understand the language of mathematicians. So, they're both about discovery, really. And depending on the teacher, um, that discovery can be done very naturally, and you can get a lot out of doing that. Because, college level courses, or at least high school, taking those in high school is a lot more free in terms of like being able to think about new problems compared to, past the courses you took before, which are mostly for preparing you at a more basic level to, in problems you might encounter after high school, but also like to, they're more standardized, right? Like every school has their algebra and geometry, trigonometry curriculum. That's not very special. But the college level courses, I think those are a lot more similar to math competitions. Though I will say that being able to solve math competition questions specifically is not, it's not the same. It probably won't help in terms of learning math in college. In that you won't see competition math problems appearing in your textbook, but being able to think in the way that competition students learn to learn, right? Um, that's a lot more important, I think. Having that insight and being able to, you know, um, see a problem in a, under multiple lights, experimenting with it, trying small cases, doing all these little strategies that you might do with a normal competition problem, that will help you get the most and like be the best at, like, it'll give you a huge advantage. It kind of gives you a top-down view of the whole environment. And if you're like me, you'll be able to make connections with, everything you're learning so far. And it just makes it so much easier and, in fact, more enjoyable to go through these, the curriculum that way. And of course, high school, college level courses are not the end. I mean, of course, there are actual college level courses, which are probably a lot more rigorous. You'll see a lot of proof-based theory in there, which means that, it's very good to also harness your, try to sharpen your proof writing skills before college, especially if you're looking into something like math as a major. So yeah, there are some skills in competition math that overlap with those in college level courses, but I would say that they're different. But each like competition math will help you get better or like think well properly with college level math, even though they're pretty like separate in terms of subjects and topics.
Okay, that's all the questions we have for now. So thank you, Adam. I'm not sure if we are taking questions from the audience.
No, we can,
Um,
sure. I
sure.
mean, we
So
have time.
yeah, so if there are any other questions you want to ask, you can send them in chat, and then Adam can answer them.
I should probably send AOP's website. I mean, I am sure all of you know about this, but yeah. And for AlphaStar, of course, advertising for my summer camp. It's not my summer camp, but here, if you look at this, hold on. Here is their list, their course catalog for the summer. If you click on that, you'll be sent to a bunch of courses. You can find them. Oh yeah. What is this? Oh yeah. Here. Here, just here's a nice website that Derrick has forwarded to me. Shoot. Here. Yeah, so that is a website that gives you a bunch of nice recommended websites, resources, connections. He makes his own problems as well, which is super cool. Because I mean, this guy's huge on AOPS. So being able to see this guy's, own thought processes through his problems, I think that's super nice to have. I think he's written some official AMCU problems and AMA problems as well. This guy is very much involved in writing questions for high school math competitions. So, I mean, all these things, his problem sets, he also makes some talks. So you can look at those as well if you're interested in research or just more advanced math in general. He also started this thing called his problem stash. It's pretty much his old questions compiled into an online competition. So if you're interested in that as well, try and look at those. I think they're about a late AMC AME level if you're looking for those sorts of questions. I worked through contest 0 and I think the questions are pretty solid. But of course there are a ton of websites that you could use. And of course there are a lot of local competitions that you can try out. There is one that has started since last year or maybe 2 years ago. It's hosted by Nanomath. So they just did their spring math meet, like a month ago. I think having new writers in the community is super exciting. So you should look at those. Let me see if I can pull that up. So yeah, Nanomaths. So they had a fall math meet in 2021 and a spring math meet this year, April. So their mission is to make questions that are more accessible to middle school and high school students, especially people who are kind of new to this, because we acknowledge that not everyone has the same experience in math competitions. So having a contest designed specifically for that community is super nice. So you can look at the Nanomath website for those that info. I'm not part of the writing community. I was for fall math meet, but not anymore. But from what I can see, there's like a multitude of writers and people who work on the logistics and checking the questions, putting everything together. So I think that's a pretty high quality contest for you if you're not as confident in your competition experience or ability. It's a good gateway into some of the more advanced competitions. Yeah, there's some more resources.
Thank you so much. Thank you so much. I don't see any questions in chat, so I think that will be where we end our talk today. Again, thank you so much, Adam, for joining us. Thank you, Mr. Das, for organizing all of our events this year. I think this is our last planned event for Math Circle in 2021 to 2022 school year.
We will have one more.
Oh, one more. Okay, maybe one more. But if we do not, if we don't, then so feel free to, if you have any questions, like over the summer, like Adam mentioned, if we want to have some bonding events, always feel free to post any questions in our Discord server. Adam and some of our older students can help answer those. join Adam's Alpha Star Camp if you have time, and also our basis math tournament. And yeah, thank you so much, Adam, for joining us. And we hope you good luck as you leave us and go to college next year. And yeah, thank you for everything that you've done for our math circle.
Yeah,
Thank
of
you,
course.
Adam. Thank you,
Thank you
Derek,
so much,
and
guys.
thank you, Irene, for hosting this. And thanks everyone for joining.
Yeah, thank you for joining.
Thank you, everyone.